Hi, welcome back ladies and gentlemen. This is lesson 4.2, Adding Integers, Part 2. We're picking up with the examples, Part 2, and we'll be finishing with Part 3. So let's see what we have to listen to today.
The sum of a number and its opposite is 0. Five plus -5 equals 0. -5 plus 5 equals 0. Two numbers that have a sum of 0 are additive inverses.
Ladies and gentlemen, this is a very important vocabulary term. Make sure you get additive inverses down, and that is the two numbers that have a sum of 0. When you have a number and its opposite, it's 0, and that is known as the additive inverse. If you need to take a moment, pause to write down a sum of a number and its opposite is 0 is known as the additive inverse.
The inverse property of addition says that every number has an additive inverse. The sum of a number and its additive inverse is 0. In the arithmetic example, 5 plus -5 equals 0, and -5 plus 5 equals 0. So 5 and -5 are additive inverses. For any number a plus -a equals 0, and -a plus a equals 0.
Okay, ladies and gentlemen, take a moment to copy this chart down into your notes. It's a very helpful chart that every number has an additive inverse and that the sum of that number and its additive inverse is 0. Arithmetic just simply means you're dealing with actual numbers. What you see is the 5 plus the -5 is 0, and the order doesn't matter. If I have -5 and I add 5, I'm still going to become 0. And with algebra, we tend to use variables, a fancy way for saying letters. So we're representing it with the letter A in this case, whether A is being added to a -a or whether -a is being added to a positive A, we see that we have 0 in either case. Make sure you have this in your notes. If you need to pause, please do so.
Drag each expression that shows a sum of two additive inverses into the additive inverses area.
Okay, so ladies and gentlemen, pause at this point, make a additive inverse box, and write down the numbers that would fit into the additive inverse. Okay, hi, welcome back. You see that I am actually trying to do this myself. So let me see what I can come up with. Hopefully I get the right answers. That could be quite embarrassing if I don't. And if you're watching me and I'm not getting something right, you're sitting there in pain, aren't you? Oops, almost made a mistake there, I believe. Let me check. Outstanding with the little dance, but you can't see me dancing. Aren't you a lucky thing today? Okay, so hopefully you had those same ones. Let's talk about why these ones are not. So in your notes, please write down a brief explanation as to why these aren't. Go ahead and pause. Okay, if you're telling me because they're both negative that they're actually the same number, that is correct. In this case, they're both positive and they're the same number. They're not going to create 0 as well as -5 adding a -5. It's going to become -10, not 0. Excellent job.
Is the value of the expression -52 plus -52 less than 0, equal to 0, or greater than 0?
Well, what do you think? Take a moment, write down what you think, and then come back and check. Hi, welcome back. As you see, I'm pulling up the solution set. We have a negative 52 and I'm adding another negative 52, so I'm getting a much smaller number, a negative $104. So it's definitely less than zero. I'm adding two negatives, so I'm going to get a negative. 52 and 52 is 104. It becomes a negative 104. Okay, part 3. We're getting there, aren't we? And just like in school, we're waiting on the technology.
Video, you will learn about the addition mode of the integer chips tool. Using the addition mode, you can model and then solve addition problems with integer chips. In the workspace are two bins, one for each addend. You can add positive or negative integer chips to the addend bins by using the positive and negative chip buttons.
These are similar to the hands-on tools you may have used in lower grades. Those little yellow chips, one side they were yellow and one side they were red. You could use the red as negative and the yellow as positive. So if this is helping you see that in that method, this is just a digital age with digital tools.
You can view the value of the contents of each bin at any time by clicking the Show Bin Value button at the top of each bin. While open, the bin value shows the value of each type of integer chip in the bin, but not the sum of different chips. When there are chips in both bins, the Model Sum button is active. You can only proceed to the Model Sum stage if the contents of an addend bin are a single integer, not an expression. If you click on the Model Sum button and this is not true, you will receive an error message. Click the X in the error message to close it. Use the eraser to correct any addend bins that are not of the same integer chip type. To proceed to the next step, click the Model Sum button. The two addends from the previous screen are now located in a single bin representing the sum. To see the expression you modeled in the previous stage, you could click on the Show Expression button. The question mark in the display means that you still need to simplify the sum of the chips in the bin by removing all zero pairs.
Basically what it's saying is you need to find the answer, but it is truly called
Drag a chip
simplifying.
on top of its opposite to create a zero pair.
By dragging it, it makes that zero pair. I know many of you will think of it as canceling, but it becomes zero. So then you can see what do you have left. You have one positive chip left. So your answer will be?
The hammer button is available when there is a zero pair in the bin. To break a zero pair apart, click the hammer button and then click on the zero pair. The hammer button is available as long as there are zero pairs in the bin. You can also disable the hammer by clicking the hammer button again. You can add zero pairs to the bin using the zero pair button. You can view the contents of the bin by clicking on the Show Bin Value button at the top of the bin. When any zero pairs are present in the sum bin, the Show Bin Value area displays a +0 term. To remove a zero pair from the sum bin, drag the zero pair into the zero pairs area at the right. Once you have removed all zero pairs, the expression display will display the final sum in place of the question mark.
And you knew that, right? Add 3 plus a negative 2 was going to give you that positive 1. We just had to sit there and watch to see how can we do that if we have a more complex situation, complex expression happening, so that we can navigate through that. This is one visual model to help you do so. Remember, this is under the tools where you would find your calculator doing digits homework.
And I win!
No.
Already?
Let's add up the scores.
In some card games, players can get both positive and negative points. Use integer chips to find each player's score after 2 turns.
Okay, so if we have Asa, I'm not sure how to say her name, and it didn't sound so well that second time I tried. Oh, sorry. I'm going to put, she has negative 12. Do I read? Okay, I need the eraser button. See? Testing, showing you how we can do this. So we're going to put 12 of these in here. And if I click up here, it's going to show me how many I have. Because if I'm busy clicking and I'm not paying attention, because I know many of you will do that, this way you can know. And then I'm going to come over here and I'm going to add positive ones over here. So she started out with 12, and then she had 12 negative ones, and now she has 5 positive. So I want to model this. Now what I can do is I can drag my pairs and they'll hook up. You can kind of see how they're doing that. I have two options. I can beat it with the hammer, or I can just drag them over. I'm not going to be so aggressive right now. If you're feeling a little aggressive, go ahead and use the hammer. So as I do this, I've now removed all my 0 pairs, and I can come down here and show my expression. Negative 12 is what I started with. I added 5. When I zeroed out those pairs, I ended up with 7 left. And if you were to count, you can see I actually have 7 negative circles. So I want you to try the rest for Dan, Joy, and Kim. Go ahead and pause. Okay, thank you for coming back. I'm going to go ahead and show you the answer set. As you see, this is what I found, although they had their chips in a much nicer arrangement. Mine's probably a little more like most of yours, just quickly done. And if you have negative 15 and negative 9, there was nothing positive to create any 0 pairs, so we have negative 24. With Joy, we have 13, and then we have a negative 21. So once we got all of our 0 pairs, which would be 13 of them, we were left with 8 negative chips. So she has a negative 8. Kim had a negative 16 and a positive 24. So we could zero out 16 pairs, leaving her with a positive 9. So she has a 9 as her final score. Go ahead and rewind this if you need to double check anything. We're going to continue to the third part, the got it. Okay.
Write and simplify an addition expression for the model.
So how many positives do we have? Then, how many negatives do we have? Okay. I came up with a negative 20, and I came up with a positive 12. So positive 12 plus a negative 20. What would that give me? Let's see. Hey, my math, I can count. So I zero out those pairs, and you're left with 8 remaining chips. Some of you might very well be able to say 12 plus negative 20 is negative 8. I don't need the chips, and that's perfectly fine. Some of you might say, I don't see 12 plus negative 20 is negative 8, and these little chip things aren't helping me. Draw a number line. Put yourself at 12 and walk back 20 steps. Walk to the left 20 steps. You will find yourself at negative 8. There are many options. Please don't get locked into just this one. We're going to do the close and check. So you'll be pulling that out of your book or flipping to it in your book, however. So here is our close and check. It's the focus question. It's all about that nothing and something and less than nothing. And then we have the directions. They do have a sample of using the chips. Remember, if you don't like using the chips, you can find that that's a negative 6. Draw that on the number line and then go to the right as many places as that is. You're welcome to use the number line. Also, the understanding, the reason, does every rational number have an additive inverse? And then make this an error analysis. See if this would, a classmate says that an additive inverse of a rational number is negative. Is he correct? Explain to me why that person would not be correct or why that person is correct. Play teacher there. Okay, thank you very much. This is the end of lesson 4-2. Our next lesson will be 4-3. So go ahead and start working on questions to bring to class.